Our final speaker is Dr. Yukio Fujinawa, who is Senior Managing Director of the Real-Time Earthquake Information Consortium based in Tokyo, Japan. He is conducting research on the practical application of real-time seismic information in general and earthquake early warning in particular. He also serves as an international consultant for the Earthquake Early Warning Project for the Taiwan National Science and Technology Center for Disaster Reduction. His research interests include telluric and electromagnetic earthquake precursors, prediction of volcanic eruption, and real-time seismology, particularly earthquake early warning. He is the winner of the 1997 Prize for Distinguished Work in Science and Technology. Dr. Fujinawa is a member of many scientific and professional associations in Japan, as well as the Seismological Society of America and the American Geophysical Union. Dr. Fujinawa, could you come up, please?
Thank you, Chairman. At first, I'd like to express my sincere thanks to Jim and Professor Hayashi of Kyoto University, who invited and recommended me to come here to present my experience and also ask our warning system in Japan. But as a matter of fact, I have been working for earthquake prediction more than 20 years. About 2 years before my retirement of National Institute for Earth Science and Disaster Prevention, my proposal for earthquake early warning system was adopted by our government. From that time, I have been dedicating myself for 9 years for earthquake early warning system. But if our government is clever enough, they should give me a fund for earthquake prediction. Anyhow, I would like to start my presentation. How can I move?
Yes, forward and back.
Okay, thank you very much. Today's content is, as you can see here, the first contents of video. Direct video will be moved to the last of my presentation because the time is not large enough. At first, I'd like to show background of our earthquake early warning systems development and operation. Third, that earthquake operation system, because Jim is kind enough to ask me at the time of invitation. He want to explain me how our system is operated and who is the player of these games. So that today's presentation, I'd like to focus this point. And fourth, utilization of and problem. I have been working for development of application system for application from different field of for countermeasures. So that at the first time, I am a planner of this system, but 2 years later, after retirement, I have been working for development of the, those application systems from the standpoint of the NGO. And there is also some shortcoming of our association, REW in Japan, so that now we are thinking about how to develop further this system to solve those problems. Seismic hazard mitigation strategy of Japan is very clear, but the first target is we have very big earthquake, for example, Tokai earthquake, which has been assumed to occur more than 20 years ago. And also Tonanka and Nanka earthquake. This earthquake is ocean bottom earthquake. And in order for this disaster mitigation, hazard assessment is done by Central Disaster Mitigation Council. And also, we have very clear numerical aims. That is a decrease by half of this and economic loss in decade. But I think maybe very difficult. How can we solve this problem? Japanese government have those means. One is a rate for house reinforcement to more than 90%. And we are now investing very large amount of funds for this target. And the second means is a tsunami hazard map, also an earthquake hazard map in all local government in coastal area and all the Japan to pass it people what will happen at the time of big earthquake. And after starting this early earthquake warning, I am believing that without using the early earthquake warning system, we cannot attain these aims to decrease by half. Then, as a background, we are using the two kind of seismic stations. One is 2,000 seismometers developed by, installed by JMA, Japan Meteorological Agency, and also more than 800 sites belong to the NEDs. As you see in this sheet, this distance about between the thermometer is about 20 or 25 kilometers. Now, before going to the detail, at the time of planning this project, I think we need a liaison system to have a cooperation between organizations in concern with this system. Usually, we think about national government institute as a need or GMA having installed a seismological station, but we need cooperation of the users, as written here, down here, government or local government or companies, and person itself and the many kind of users, so that we coordinate such a kind of liaison system that's like. Now we have more than 150, about 150 organization person to help us to have a cooperation to have a successful result to using the earthquake system. At the time when the preliminary studies started at the time of 2002, and about 1 year, we have get a very quick hypocentral determination system, as shown here. As you can see here, this is a real solution at the time of 2009 and September 16th occurred near Tottori. You can see the performance of the algorithm rapid determination system. You can see that here, just after about 2 seconds, we start to get the solution or reasonably result. After getting this result, we propose the government to make this system practical with the cooperation of our institute and also JMA. This is a research around the scheme at that time, from starting 2003 and 2007. This is my, at the first stage, I am planner of this system. And here, there are two players to make the analysis system. This is a JMA. They have already started new system originate so-called UREDAS. It is used by railroad company. It start about 1990s. And we also have a real-time systems developed by us. In this new practical system, we combine these two systems so that even now we have a historical effect of practical system. And here the non-government performance is like, and also JWAs. Japan Weather Association is have a role to investigate on the issue Earth global area system on sociological phases. And in the application system, we developed about 14 contents to be used in a different application system for fire and department office and mobile building and plant and elevator so. And after preliminary stages of experiment by using the area system by JMA, they concluded that area system can decrease earthquake damage if it is adequately used. And it is a fundamental information to be delivered to all people, not to limit organization or persons. So that in order to have a very effective use, we need environment of generals. That means we need a very elaborate teaching and learning system. This is a development practice system by GMAs. As you know, they started 2000. Practice system is started to develop by GMAs. And with the cooperation with the Japan Railway Technical Research Institute, they started to develop NAUCA system. And from the 2002, they cooperate with the need. And 2004, they started trial uses in the limited area near metropolitan Tokyo. And 2005, they extended trial station nearly all over Japan. And another epoch meeting is 2005. They integrated the analysis system developed by need. And another epoch is 2006. They started service for advanced users. That means they do not use a broadcasting system to general public. But at that time, everybody who wants to use the system can be allowed. And from the 2006, they started to intensive public educations about earthquake warning. They broadcasting using the TV every day or every week. They how to use to these informations. And the most important time is 2007 October. They start service to